find it pretty fitting coming right outside of a blizzard. That's Dr. Aaron Kennedy from the University of North Dakota Atmospheric Sciences Department, and he's doing some research on blowing snow that leads to all these nasty events that shut down our state. Aaron, how are you doing today? Thanks for joining us.
I'm great. The sun's out. It's nice out. We had bad weather yesterday. What?
Yeah.
So tell me about this grant that you've just received. I believe this just started on March 1st. You were included in an article back in February about this grant from the
Yeah.
National Science Foundation to continue ongoing research you're doing on these blowing snow and blizzard events.
Yeah. So this is a collaborative project. We're actually working with Ohio State University, and my part is the observation. So we want to know how these blizzards and ground blizzards work. We're going to put up weather balloons that have really unique instruments on them. We've got surface instruments. Like I've built a snowflake camera. It actually takes pictures of the snowflakes as they go by, and just trying to figure out, is it snowing, is it blowing, is it both? What's going on, right? And those observations are what we need to make the weather models better. And so my friends out at Iowa State University, Dave Bromwich and his crew, they're actually polar and Antarctic researchers. And so they've got a special weather model that has blowing snow in it. And so something the viewers may not know is our current weather models that we use, they don't have blowing snow in it. So the snow falls out of the sky, it reaches the ground, and then it just melts, right? And that's not how it works in our neck of the woods. And so my friends at Ohio State are going to run this model that has the blowing snow in it, and we want to see what happens. Can we actually simulate these ground blizzards? And if not, how do we make it simulate them?
Right. So with this information that you're obtaining, are you trying to match it up to what these special models are indicating to see if what they're indicating is what's actually happening in real life?
Yeah, I think the goal is we want to make sure that the blowing snow that's in this model actually works right. And then if it is, that gives us evidence that, hey, you know what, we can include this in our weather models that NOAA and the National Weather Service use. That way their forecasters have the best possible information when they make a forecast, right? And so I really work behind the scenes. My goal is to make you and your viewers be less angry at meteorologists when we blow a forecast.
So why is it that you think that the models don't have this in them right now? Because us as meteorologists and forecasters know that even forecasting snow in general, yet alone the exact impacts to individual spots with a blizzard is extremely challenging. And the general public doesn't quite understand exactly how much goes into it. And a lot of times you get missed forecast, or, hey, it hits really hard right here, but you go so many miles east and it's not quite as bad. Why do you think that is?
Well, a lot of it just comes into the observations are going into the models, right? There's really, in the scheme of things, not that many, especially for the type of processes I'm looking at, like blowing snow. So I think historically, if you look at like, why isn't this actually in our models? It's because we just don't have the observations to figure out how we would put in the models to start with, right? The starting point we're using is some research that came out of the Canadian prairies. So farther up the way, the Canadians are probably a little ahead of us in terms of like forecasting blowing snow. And so we're trying to incorporate some of their methods, put it into our models, and see what happens.
Now, Aaron, would this be used for just, I'm guessing, the short-term models, the HER, the RAP, stuff like that? I'm guessing it.
Yeah, so yeah, that's what we're doing, is we're using for the short-term models. And so I have a student right now that he's taking the HER and the RAP and that type of model output and then driving a blowing snow model to see, okay, how does it do? And then the real fun part is actually putting the process in the weather models. And so what I like to tell people is, you get out of the shower and you feel cold, right? That water's evaporating. Well, actually, when you get blowing snow in the atmosphere, it can sublimate. It can go from that frozen state to gas. That actually causes cooling. And so we think that sometimes our forecasts are wrong because we don't get that cooling in the atmosphere that happens because the process isn't in the model to start with. Like you can't expect the model to be right if it doesn't even have the natural process occurring in it that's really there.
What kind of results have you? First of all, how long have you been doing this research, and what kind of results have you seen from it so far?
Yeah, so I guess you live in North Dakota long enough and winter rubs off on you, right? And so I started off as a severe weather meteorologist. I did a lot of work with like supercell thunderstorms, which Justin knows all about, and tornadoes, and looking at them with radar and stuff. And I moved up from Oklahoma to here in 2006, and then at that point, I was funded to do some other more climate-related research. And then finally, 2013 is when I started my faculty job, and at that point, the puzzle pieces were spinning in my brain. I was talking to the Weather Service, said, I had some questions about this stuff, and they didn't have the answers. And I looked at the science in the field, and they didn't have the answers. And the brain keeps spinning, right? And so I started doing winter weather research, and now that's sort of like my bread and butter now. Like I just, when the winter's bad, I love it.
Well, you're living in the right place, that's for sure.
I know, right?
So with that work, I am the ag director, knowing more about farming here than blizzards exactly, but tell me what I can learn from that if I've got livestock, etc. Where's that research going to lead us? What do I get to use it for?
So I think probably the biggest impact to come out of this will just be a better forecast when we expect the blowing snow and when it may not be blowing around. Yesterday was actually a pretty good example of how complex these events can be. At the end of the day, we need wind to cause blowing snow. At least at my field site, west of Grand Forks, it really wasn't all that bad. Most of the winds are a little bit stronger out of the valley. And so a lot of the fun stuff we're going to be doing is looking at how does the valley and like the Turtle Mountains and these different regional features, how does that really impact our weather systems? And so we're actually going to be taking the weather model and running an event and seeing how it produces blowing snow and falling snow. And then we're going to have a lot of fun, and we're going to remove the Turtle Mountains. We're going to remove the valley and just make it a flat surface and see, does the weather pattern happen the same way? And the hope is by doing that, we'll understand just how important the valley impacts are. So, how much funneling and wind do we get down the valley? Why, in some cases, is the blowing snow limited to the valley? In other cases, it's more widespread. There's a lot of things that go into that.
So I'm also curious, you mentioned climate dollars and or dollars for research for climate change, et cetera. Do you think that there's more money available as of late for that? And I've heard a couple of banks are making changes that they're not going to spend as much on that kind of research. But what do you think from your end of it?
From my end, I mean, there's always like what I would call like climate system research. And so that type of work is focused on like seasonal prediction, longer term prediction. For example, the blowing snow stuff, like how do I get this research funded? Well, it depends on the agency, right? And so in Antarctica and the North Pole and these areas, blowing snow is really important because it's part of what we call the mass balance of the snow at the surface. And so over long periods of time, if you don't have blowing snow in the model, you're not going to identify properly whether that glacier is going to grow or decay. So it has long-term impacts on what happens to the light and reflecting back to space, that type of stuff. Here, of course, we care because it impacts us, right? Like, are we going to go to grandma's house today? Well, no, because of the blizzard, right? And so if I'm writing a proposal to NOAA, I'm saying, hey, this is a life and death type of process. You could get stuck in the countryside. Bad things are going to happen. We need to better forecast this. If I'm going to an agency like the Department of Energy, which is focused more on energy systems, climate, that type of stuff, then I'm, I don't want to say playing, but I'm advertising more of what are the long-term impacts of blowing snow, what that means for our Earth system models. And then there's even other, like the National Science Foundation stuff, there's certainly impacts on us, but it's more like the core meat and potatoes of the science, the basic science research. This cooling that happens with blowing snow doesn't matter. Like, do we need this in our weather models, or does it turn out that it's really not that important and we don't have to worry about it? Because if we don't have to worry about it, that means we can make our weather models like less complex than they need to be, and that means they could run faster, and it's not a big deal.
Maybe I can.
We had
travel
an email
more,
question. Yeah, Bridget seems to be traveling every single day. There's a bad storm this year. It's so unfortunate for her. But we had an emailer question come in. They were wondering, how do you go about submitting your work? Does it just get sent to the University of North Dakota, or is it like weather and science journals that are getting looked at? Where does this information go once you obtain it?
Yeah, so actually one of the great things that the government's doing right now is really pushing towards what we call open science, so no one can hide behind the work they're doing. And so what happens is I write a proposal, and so I spend a bunch of time. You want to have maybe some sample data or something, and then I write this proposal, and then the university puts their name on it, and it goes to whatever agency is interested. Maybe it's Department of Energy, maybe it's NOAA, maybe National Science Foundation, maybe it's Department of Defense. I have some DoD projects. And then it goes off, and then I call it the academic lottery. And so you put all this time and effort in the proposal, and does it actually get funded, right? And so what happens is it goes before basically a judge and jury panel, and it could be scientists, it could be people within the agencies, and they look at your proposal and a bunch of other proposals, and they decide, okay, is the science sound? And if it's sound, it doesn't match the program priorities. For example, with my NOAA project, they were looking for innovative winter observations, and that's like what my snowflake camera does. And they decided, yeah, you know what, it does. The scientists liked it, and so, okay, we're going to give it the green light to get funded. Then you get that funding. A tiny, tiny, tiny piece of that pays for like a month of my salary for the year. The rest goes to typically grad students, keeping the lights on in institution. A little bit of that money goes toward making sure the science is made public so people can actually act upon it. And so that could end up being journal articles. And so it goes into journals from like the American Meteorological Society or from American Geophysical Union or whatever journals are out there. And all of these journals are now pushing open science. And so what happens is when I publish a paper, I have a website where you can actually look at the computer code that I use to generate my analysis. It has the data. You can basically reproduce my study. And that's a good thing, right? That basically means that you're not going to have these scare stories that sometimes come out of, like, say, the biomed field where people fabricated data, right? It's happened. You know, it's happened before. I like to think in our community, there's a lot less chance of that happening just because so much of our data is public. And so a little more taxpayer dollars go to making our satellite data public or radar data public or whatever. And that's a good thing for us because that makes the science more sound at the end of the day. So yeah, the science goes out there, publications and all sorts of fun places.
Awesome. Thanks for the explanation on that. We're going to hit bottom of the hour real quick. When we come back, you know, this isn't just research that you personally are doing it. The university is getting involved as well. Graduate and undergraduate students are getting their hands on what it's like being in the field, obtaining this information and knowledge, and possibly leading them into a field of their career. So when we come back, we'll tackle that, a few more questions. And Aaron, I was teasing into a question, but before I get to that, I got another one that I want to answer. In this article that was written about you, you were mentioned that we've taken all the lessons that you've learned over the last few years to conduct the largest field campaign in blowing snow in the region. Because this isn't your first research project, you've had a couple more, and I was involved in one of them a few years ago. But what goes into these past research projects that makes them the largest, and why is blowing snow and blizzard such an under-researched thing?
Well, I guess at the end of the day, there's just not that many of us living up here, right? And actually, some of the first proposals I wrote, I remember a viewer said, nobody lives in the Northern Plains. Why should we fund this? That's basically what they said. And that made me pretty salty, right? And so thankfully that's changed. We've had some really good luck, but it came down to marketing, you know, saying, look, I don't necessarily think not many people here live here or whatever, but I say, you know what, this is why it impacts other areas, why you should care, right? And then finally people are like, okay, we'll fund you. But, you know, what makes this the biggest campaign for this upcoming project is we're going to, normally, you know, we'll launch a weather balloon from Grand Forks or whatever, but we really, really want to understand the spatial variability, like how much these blizzards vary from across the valley and the region. And so we're going to have a sounding site located just out of the valley, out more towards the Devil's Lake. We're going to have another one up by Hallock in Minnesota. And then we'll have some other instruments up there. We're deploying instruments across the North Dakota Agricultural Weather Network. And so NDON is a huge, huge partner with us. They've been awesome to work with. We have like what I would call the winter weather testbed NDON site out west of town. And they'll be putting some instruments on their stations. And so really it's just going to be the number of students we have involved on this project. We'll have a student team at each sounding location. We're going to do these weather balloons. We'll have the weather balloon location in town. and then utilizing all the other stuff we have in the area, weather radars and so on, to make this a really, really large project. And it's going to be fun.
That's awesome. Hey, Aaron, so when all is said and done and the research is done here, obviously this is, like you said, to help improve the forecasting. And would this change any parameters in terms of, and I've got kind of a follow-up, would this possibly change the parameters of how the National Weather Service issues a blizzard warning, or maybe change the criteria of what would constitute a blizzard?
Well, I'm not going to go into the details of like how the Weather Service defines products and how they issue it, because that's a whole other ballgame, right?
Right.
But what would happen is, like, right now, the Weather Service uses like statistical models where they say, well, based off these events we've had in the past, here's what we think the probability of blowing snow is, right? And that's coming separate from what the actual weather models are outputting, because the weather models don't say anything about blowing snow. What our research would do is say, hey, just like we have like a precipitation output or a snowfall output from the model, it would also have something that says, hey, here's where the blowing snow is, how intense it will be, here's what the visibility reduction would be. And then what can happen is they can tie that into all of their other models and then come up with the actual probability of what the blowing snow impacts would be.
Okay. And how soon do you plan on having the research done and maybe having this model fully implemented with the National Weather Service and other agencies?
That will be a long time.
Okay.
So good science is slow and methodical,
Sure.
right? And so where we're at right now is we're doing these simplified model runs right now, and then the next 2 years will be focused. Like, so next winter and the following winter, we'll be doing our big field campaign. We'll use those observations to verify what's happening in the actual weather model. And if we get good results, that's actually where we'd write the next proposal that says, okay, now we're going to include this into the model that NOAA uses and put it in the hands of the Weather Service to see what happens.
Kind of like an experimental model they could use.
Yep, exactly.
Okay.
There's a lot of experimental models right now for like convective, like severe storm weather. We want the same thing except for winter weather, right?
Mm-hmm.
And they have some very rudimentary ways they're doing blowing snow right now. I don't think it's very good, to be honest with you. So I think I can do it better. So that's what I'm going to do, and we'll see who the winner is. And you know what? Even if I'm not the winner and they are, that's okay, because at the end of the day, we benefit.
Yeah.
So a part of science is failing, right? That's. Go ahead.
Yeah, is finding out you're failing, but yet you're finding out of that, and that's what matters the most.
Yep.
Which leads me to my question for you: what's changed, or what have you learned from the onset of the start of this research to where you are now? Have there been any big aha moments for you?
Yeah, so I think the coolest thing is that these blowing snow events actually behave sort of like miniature thunderstorms. And so we refer to thunderstorms as convection. It's like air moving upward in the atmosphere. And what we're finding is some of these ground blizzards are actually a type of convection. It's just very, very shallow, and there isn't lightning and thunder. But because it's convection, it can have a lot of variability, right? And so in town, the conditions might look nice, blue sky. Hey, what's that white thing on the horizon? Well, that's the convective roll that you just drove into that has the blowing snow and the blizzard conditions, right? And it's a tale of two situations. In one part of the road, you're perfectly fine, and you go a mile down the road and you're miserable and you're stuck, right? And we really want to be able to simulate this type of stuff so we can tell people whether the conditions will be super widespread, white out everywhere, or is it going to be more scattered where, okay, just get past this one little convective roll and you'll be okay, and then maybe hang out in the clear area for a while so you don't get stuck.
When it comes to the involvement of the students that are engaging in this with you, because you're doing a lot of it for the educational purposes for the graduate students as well as the undergraduate students, you had mentioned that they're getting involved by helping launch the balloons, planning for the weather events, you do forecasting, briefings ahead of time, everyone's on the same plan. What's been the feedback from the graduate and undergraduate students that you teach in return? What do they think about all this research and getting out of it?
Well, the students are generally like me. The less I'm in front of a computer, the more I'm out in the field actually observing and learning things. That's what's exciting, right? And that's probably the coolest thing about our field is we're all about observing and seeing what's happening and getting out there, launching a weather balloon into one of these convective rolls with blowing snow. It's fun, right? You freeze your butt off doing it, but it's rewarding, especially when you get that balloon off the ground, you don't hit a light post or whatever, you know. And when we had like the radar truck out there, the picture of you leaving the radar truck is just, that really epitomizes what science is all about. And we took that radar truck, Justin knows, and we destroyed it. Like it was stuck on that road for days afterwards, right? And so we used
one of 4 in the entire United States.
Yeah.
That brings up an interesting point there, because you brought out the Doppler on wheels, you know, the big radar truck from the Weather Channel storm chasing series back in the day. And you use that to gather very low level scans of that shallow low of potential convection, what the snow is actually doing. And you get this thing between the Mayville radar, there's a radar on top of the university, I believe it's Clifford Hall or Odegaard. Both of them, I think, might have one. You get something called dual radar, and you get different products you can get from that. But when you implement this third radar from the Doppler on wheels, you get a tri-radar. What's the benefits of having 3 radars to scan an event like this?
So in that case, it was, you could actually map out what the exact air motions are. It turns out that actually combining the 3 radar data is super difficult, though, with all there's what you call ground clutter. So you're hitting like power lines and stuff like that. And so I actually, for this upcoming proposal, I didn't actually put in weather radars, because I think we can actually use these instruments called LiDARs, which is sort of like a radar, but using a laser. And that will give us most of the information we need. And it's a lot less expensive to have a LiDAR than a radar truck out there. So that's another part, right? Is I could propose the moon, right? But there is a finite number of dollars out there for research. And so you have certain numbers you have to hit. You have to be economical about how you're doing your science, right? And if you're going to bring out the heavy hitters, you really, really have to have strong justification about why we need to spend millions of dollars to do something.
Mm-hmm.
And that's important, right? Because at the end of the day, all of your viewers and you guys are helping support my research with some fraction of a cent that came out of your taxes, and I'm cognizant of that, right? I'm thankful that we have this type of research, because I think it makes our weather community really great in our country, and that's why we're leaders and so much stuff comes to weather.
And Aaron, we're running out of time here, so a couple of quick last questions. Have you found it more gratifying to do research on severe weather or this project you're on right now?
That's a good question. I tell you what, you know, doing a storm chasing field campaign is pretty exciting. Staying at random motels across the southern Central Plains, not so exciting.
Right.
So I tell you what, I've stayed in the motel in Hallock before. That place is pretty solid. Anywhere up here, I'm happy to stay. And you know, when you have a field campaign that's sort of fixed in location, it makes the logistics a lot easier than traveling wherever the storms may be. And
I can imagine.
I think that's a little more
And okay, one last question. I've been in this business over 25 years, and I've worked with a lot of fresh meteorologists out of school. Justin, and I will honestly say, you know, I give him so much grief. He's probably one of the smartest meteorologists I've worked with that has just come out of school. Now, my question is, what was he really like? Did he sleep in class? I mean, did he really get anything done?
You know what? I would never judge a student if he slept in class. That's what I did. And also, I'm not going to tell you how many days of class I missed storm chasing in Oklahoma, but it was probably too many. But here I am today, and I think at the end of the day, it benefited me. And I guess in Justin, I saw a little bit of me because he loves storm chasing and getting out there and actually observing. And that's where my passion is. So I love students like Justin.
See, Justin, there's
thanks,
hope.
Aaron.
There's hope. There's hope for you, Justin. See?
Oh, thankfully. There we go.
But you guys,
I don't even remember what
seen
Justin's grades were, and I wouldn't be able to discuss them anyway. So it's no big deal.
Yeah. But here's the thing: we've seen Justin drive. So how in the world could he chase a storm? Was it
Oh
moving that
man,
slow?
he drives slower than my grandma. Oh,
Well, we probably need more of that in the storm community right now.
that's a good point.
Yeah.